we're going to do the same thing here for VLAN 2 on the same switch 1, or VLAN, switch 1 VLAN 40, which have the ports 14 through 15. Okay, we can verify our changes with the do show interfaces status. You see how we have here port 14 and 15 on switch 1 connected to VLAN 40, and then switch 1 ports 11 and 10 and 11 on VLAN 30. So we're just going to keep doing that for the next set of VLANs on switch 1. Well, actually, we're going to go over to switch 2 for these. It's 2 VLANs per switch, so we got to go over to VLAN 2. Switch 2, which has VLAN 50 and VLAN 60 on there, and ports 10 and 11 and ports 14 and 15. Basically the same thing here, applied on switch 2. Okay, great. So what we've done so far is steps 1 through 3. We've done our adding our layer 2 and layer 3 routers. Routers are always layer 3, by the way. It's just distinguishing it there. We got VLANs and trunks between the routers and the switches. And we also have port security running on the switch ports where the end users are. So the next thing we need to do is load balance and redundancy between these two switches. What that means is, since these interfaces are trunking, and they're going to eventually do some routing between these routers to these other virtual local area networks. Suppose one of these switches were gone. That load balancing effect will allow this switch to take over. And if this switch wasn't here, in effect would allow this switch to take over and pass the VLANs accordingly. It's also good to run this EtherChannel, the EtherChannel. That's what it really is. The EtherChannel protocol. The grouping of these two cables allows spanning tree, which will normally try to catch loops of packets being sent between these clients and between these switches. What it would do is it would altogether eliminate spanning tree protocol, because it's going to logically bundle these cables together. Each one of these blinking lights is supposed to represent the interface. And apparently, if we look here on switch 2, F04 in the spanning tree protocol is going to be blocking or alternate, depending on which version of spanning tree is running. And actually, we have a per VLAN spanning tree, or no, we just have multiple instances of VLAN running, STP running, because we have different VLANs running. But let's see. In VLAN 1, for instance, on switch 2, Switchport 4 is blocking. Same for VLAN 30 is blocking. Same for 40 is blocking. So STP is designed to prevent packets from reaching an interface. And if it doesn't have the right, I say, elections, then the bridge protocol data unit is what switches pass between one another. It's going to have some confusion and not necessarily know where to go. And STP prevents that loop between switches and helping decide which path is better to send the frame at the layer 2 level. They become packets at the layer 3. So let's go ahead and bundle our EtherChannel. And it says here to use the Cisco proprietary protocol with switch 2 actively negotiating. So that's going to be channel protocol PAgP, which is port aggregation grouping protocol, which runs with the active and passive port statuses. And we build our actual interface our ether channel with the command interface, and I think that is port channel. We'll name it port channel 1. And then when we go to apply it, we're going to do channel group 1 from the same port channel 1, and mode, it says for switch 1, switch 2 is going to be actively negotiated. So switch 1's range of ports should be passive. And we're going to do the same thing here for switch 2, except for make those ports actively negotiating PAgP for ether channel. Yep. Didn't like this because it's the way we applied it in the order we applied it. So let's go ahead and build this out here the right way. Oops, that's not the right one. There it is. Right. So see how we're in interface port channel 1? We need to be across the interfaces in order to apply the channel group mode to them. So it's a double check. Let's see. Yep, here it is. And on switch 2, we are actively negotiating. It says it's already a part of a protocol or port channel with a different type of protocol enabled. So let's go over to switch 1 just to double check what's going on over here. Okay, so let's see. Doesn't like this command because active command is rejected. It's already a part of a channel with a different protocol enabled. So I tried. Okay, see, that's where I misspoke. And active and passive is for LACP. And PAgP, port aggregation control protocol, is desirable and auto. So let's go over here and change that. It still would be actively negotiating with PAgP if you choose the command desirable and the command auto for the other side. So let's go ahead and just change that. We're going to have you passive, so that means auto. And we're going to have on switch 1 and on switch 2, we're going to have actively negotiating, so that's desirable. Let's go over to switch 1. It's the order, so let's get the order right. Okay, great. And if we advance packet tracer, we're going to be able to see when we run the do show. And then we got a notification that the port channel is up, port channel 1. We're just going to run do show ether channel to see the port statuses. Okay, good. S means we're running port channel in layer 2, and that's good because we're on layer 2 switches. And U is in use, and then the P is for in port channel, so that's great. The next thing we need to do is define our router interfaces for IP addressing. And so it looks like router 1 here is going to run two different networks, 10.12 and 10.17.0.1/30s on different interfaces. And then across from the interfaces, like for instance, across from router 1, G01 is router 2's G01. Let's see, let's double check. Yep. So we'll make a change here. And so if the G01 on router 1 is going to have a .17, so should the G01 on router 2 should also have a corresponding address in the same subnet as a .2. And for router 2, we're going to choose port 2. I think this is port 2. Let's just double check. Yep, that's port 2, router 2. It's going to have a .15, and across from router 2, 10.15.0.0 network, router 3's interface, I mislabeled that, is a G01 as well. So let's go ahead, and it should have an address in the .15 as well, across from this G02, I believe. It's G01 and G02. Yep, router 2, G02, and router 3, G01. So on router 3's G00, I believe this is, let's double check. Router 3's G00, which is in the .17, is across from router 1's G02. Let's double check. Let's see. So router 3 G00 is in the .17. So router 1's G02 is in the .17. And the G01, let's double check, should be the 15, because the R2 G01 is the 15. So I think we're going around in a loop. We could effectively pick just decide which one we're going to have. So we're going to have between router 3 0 0 0 and router 2's G01 the 17. So G0, so that matches router 1 17, router 3 17 for router 1's G02 and router 3's G00. Good. So let's go ahead and label that. And router 3 was a .2, and router 1 is a .1. This is just a point-to-point network. So, and then router 3's. This is router 3's G01. Looks like it's in the .15, and router 2's G02 should also be in the .15. And it is. Router 2 is the .1, and router 3 is the .2. So we'll go ahead and make a label here. And that matches. We'll also add our network, which is that was router 2, and it's G02 interface, I think that is. Yep, and that's the 10.15.0.0/30 network. And this one's going to be by default. We're running 3 of them, so we're going to use a .12 here. We can deduce which interfaces this one's going to go on, because now we have router 3 with its interface G02. Router 3, excuse me, let's see. Yep, router 3's G02 is the 15. Let's make that a 15.02. And then router 3's, I think that's a G01, is our .12. So that means across from our router 3 G01 is a G01 on router 1, which should be a .12. It's a G01, router 1 should be a .12. So there we are. A little bit of confusion there, but which router ports go to which, but we're matching now. 1 2 1 2 and then 1 2. So we're okay. We got our matching ports here. Let's triple check. Router 1 G02 .17 01. That's good. We can even make labels, because let's see, router 2 G02 is the .17. Yep, and that's a G00 above for router 3. And then so 1017, let's make this cleaner than that. 1017 router 1 is going to have G02 at port 1017. That's good. And then router 3's G00 is supposed to be a 1017 as well. And we're going to put those together just so we can avoid further confusion. Okay, great. And then on ports, router 1, G01 is the 12 network, 10.12 network across from router 2's G01. So G01 to G01, both in the 12. And then for router 2, G0, let's go ahead and label it G02 to G01. and that should be running our .15. Our G02 for router 2 should be our .15, and we're using that as a .1. And then across, which is router 3's G01, should be a .2 in the 1015. Okay, great. So let's go ahead and configure our router interfaces. Router 1 has, so let's see, router 1 has a 10.17.0.1, and its corresponding network is router 3's 10.17.0.2, but its G01 interface is a .12.0.1, and then we have both router interfaces configured. Now we'll go over to router 2 and get both of those interfaces configured.